In this video, I'm overviewing an example of coding best practices. So I'm going to start with github.com/AshleyFV. We're going to go to BeeNestABM. This is a peer-reviewed software package that collaborators and I put together. I'm going to scroll up for the purposes of viewing better. This is a public open source equivalent of a GitHub or it is a GitHub repository. This is where we have our files stored for Git and version control. So there's a number of files here. And scroll down, we have a README file that tells what the name of this project is, that we have the code is stored as, it has a DOI number, and there's a paper associated with this. I want to point out the log part. So if we click on the commits, that's essentially a log that tells us all the different times we've updated files, and we can look across the history of the project and see different specific commits that have happened over time and what those changes entail. So that is a log. Writing thorough comments and documentation. I'm going to show you the documentation now. So this is in the README. We have a image file. This is the output of our project. We have a caption for the figure. We have a list of the authors of this project and our contact information at the time that we wrote this. We have a brief overview. It was helpful to tell what the main files are so that we can say what is the actual file we need to be able to run this. So if you want to do a custom simulation, you look at the list of files above and run model bscript.m, which is a MATLAB file. If you want to do a couple of different simulations, you can use either of these options. We also have a GUI for those that don't want to interact with the code itself, but want to run the model and visualize the results. And then we explain what some of the other dependent files are and give our references. But this is a modeling type that is traditionally quite hard to replicate if people don't share their code. So we adopted a standard for documentation that explicitly identifies certain properties of this code so that other people could more easily replicate it and understand what we have done. So that's what all of this is about, and we've included some figures in our documentation. We did all of this using Markdown text in GitHub. So different layers here of the principles. So quite an extensive set of documentation, and this figure that explains all of our different code choices, the flowchart, and then some of these code samples. Rather than having someone look through several subfiles and hundreds of lines of code, we just put the key relevant code to demonstrate some of our choices here. So that is the most verbose documentation that I have, but it meant to be really helpful to people who wanted to reuse our model. So I'm going to open that code that I said was the main file here. It's model bscript.m. This is a script. It involves setting some options at the beginning. It tells us what our inputs are, and it clearly defines this is the nest chamber size, and we've used descriptive variable names. We said this is the nest maximum X. This is a 2D grid that has units of meters. Nest max Y, so you can interpret using these descriptive variable names that this is probably the maximum X direction or X dimension of the nest, and this is the maximum Y dimension of the nest. The number of bees, we called the variable num bees. Number of repeated trials, or repeated simulations, we called it num trials. Fraction of bees treated, frac treated. So we tried to be very intentional with our variable names so that we could understand and have readable code. We also used plenty of white space here. We named all of our parameters. We didn't just somewhere embed this number, but we gave it a name so that we could change it. We put all of these input parameters in a 152-line script starting at the top so that if users wanted to change them, they could. They didn't have to go dig into our other files in order to find where that parameter was defined. We give initial positions, other things. We also use indentation to specify where our for loops and our if statements are. Again, we've given units when they're appropriate. We want to run a certain model. Here, we want to run this simulation num trials numbers of times. So rather than rewriting it, we have it run a loop. And we have a specific file called simulation output spatial. The idea is that we could change the number of these loops. So we have a separate file called simulation output spatial that then can take in the information about the bee colony, some estimated data. All of these things are specified above. Now we've given some default values. Users could specify something else, but they would be able to run this code. If we only gave it simulation output spatial, then you would have to know what even kind of data goes into this spot called colony. Well, you can look here. Colony is a structure that has specific information. Colony already is a file that exists in this folder. And so there's certain information that we're able to pass into here. So because we're going to reuse this file often, it is a separate code that then we can reuse many times without redefining it. Similarly, in simulation output spatial, I'm going to go to that code. We have these are parameters that stay constant. So we want to plot coordinates. We're going to need to plot coordinates many different times. That is another thing that we do as a loop, and that has rather than rewriting it, we're going to be able to plot the coordinates of the bees and where their nest structures are. We want to be able to do that multiple times. So we wrote a separate code to do that. Rather than writing out all of those lines of codes here, we have one file that we can run in other locations. All right. We don't generally use global variables. These would be variables that we say the word global and they're available everywhere. We tend to explicitly define the variables we want to name. That way, in case we close the file, other things, we know exactly what we've specified and we don't have any weird lingering global things that affect our code in ways we don't anticipate. So with this, we purposely shared our code so that if other people wanted to use ours, they could adapt this existing code to suit their needs rather than starting from scratch. And so that is a guiding principle also for coding best practices. If I want to start a new agent-based model, I'm probably going to start from this repository of our BeeNestABM project to be able to not have to start from scratch again. And so in general, these are my short list of best practices from the reading. Many different best practices are espoused, but this is the list that I really resound with and that we try to implement in our coding projects. And so throughout this course and the exercises, I'll be emphasizing these specific coding best practices.